Good morning. I'm Pratik Bora, and we are here to give the presentation for our digital signal processing subject on the topic features of digital signal processor. Our group members are Om Salga, Sudeep Karajangi, and Ronit Birla. Introduction. Introduction consists of the several parts like application specific processor, manufacturer, Texas Instruments, analog devices, and Motorola. Two types: 16 bits points and 32-bit floating point TMS 320C5X. Fifth generation 16-bit fixed point processor. Instrument sets are upward compatible. Fixed floating point processor. There are two types of fixed floating point processor. First is 16-bit fixed point processor C1X, C2X, C2XX, C5X. Second is 32-bit floating point processor, which is C3X and C4X. It consists of two types of architecture. First is hardware and second is non-human architecture. Hardware and non-human architecture, which fetches instructions and data from one memory, limits operating bandwidth to separate memory spaces for instruction and data increasing throughout different programs and data bus which are possible. Non-human architecture. This is the block diagram for the non-human architecture. Hardware architecture. This is the following diagram for the hardware architecture. This is all concluded by my side. Next part will be explained by the Ronit Birla.
I'm Ronit Birla. I'm explaining the RISC and CISC architecture, and this is the architecture for RISC and CISC. What is a RISC? So RISC is a complex instruction set computer, and its feature is instruction can operates directly on memory. Small number of general purpose register. Instructions take multiple clocks to execute. Next is RISC. So RISC is reduced instruction set computer. RISC is a CPU design that recognize only a limited number of instruction. Simple instruction. Instructions are executed quickly. Feature of RISC: reduce instruction set, execute a series of simple instruction instead of complex instruction. Instruction are executed within one clock cycle. Incorporate a large number of general registers for arithmetic operation to avoid storing variable on a stack memory. Only the load and store instruction operating directly onto memory. And pipelining. Next point is pipelining. Pipelining is a method that fetching the next instruction while the current instruction is decoding. The fundamental idea is to split the processing of a computer instruction into series of independent steps. The steps are fetch, decode, and memory read and execute. Next part will be covered by Om Salgar.
These are some addressing modes: direct addressing mode, indirect addressing mode, immediate addressing mode, memory mapped register addressing, circular addressing. First, we will see immediate addressing. Load either a 16-bit constant or a constant of length 13, 9, or 7. Accordingly, it is referred to as long immediate or short immediate addressing mode. It is indicated by symbol hashtag. Example: add hashtag 56H and add hashtag 4321H. Next one is direct addressing mode. This is the diagram for example of direct addressing mode. Next, indirect addressing mode. This is diagram of indirect addressing mode. In this diagram, we can see the data bus. Next one is memory mapped register addressing mode. In that we have four types: LAAM, LMMR, SAMM, SMMR. Next one is circular addressing mode. Algorithms such as convolution, correlation, and FIR use circular buffers in memory. This was from my side. Next slide will be explained by Sudeep.
Hello, my name is Sudeep. I'm going to explain about the architecture and its description. So first is the processor is running at 40 megahertz. Execution time of single instruction is 50 nanoseconds. On-chip memory include 10K words of RAM and 2K words of ROM. The function block is divided into 4 sub-blocks, which is bus structure, CPU, on-chip memory, and on-chip peripherals. Bus structure. There are various different types of buses, such as program bus, which interconnects CPU and program memory. Program address bus, which provides address to program memory space for read and write operation. Data bus, interconnects various elements in CPU and data memory. Data address bus, it provides the address to access the data. Next is CPU, which is Central Processing Unit. The Central Arithmetic Logic Unit, MAC, 16:16 parallel multiplier, 32-bit accumulator, and the 32-bit ACC buffer. Product register, additional shifter. Parallel logic unit, logical operations, which perform logical operations. Auxiliary register arithmetic unit, which has AR0 to AR7, ARP, and indirect addressing. Next is memory mapped register, SFR, which is 000 to 5. Next is program controller and a program counter. It has status and control registers, 4 status registers and control registers. Hardware stack, 8 level deep and 16-bit wide. Program memory address generation logic, address generation by program counter, and instruction register hold the opcode. On-chip memory. On-chip memory is the memory address range is 244K words into 16 bits, and memory space is divided into 4 memory segments. 64K words program memory space, 64K words local data memory space, 64K words input output ports, and 32K words global data memory space. On-chip memory includes PROM, MP/MC. Data program single access RAM, and data program dual access RAM. On-chip peripherals. It consists of clock generator, which has internal oscillator and PLL, hardware timer, generate CPU interrupts, software programmable wait state generator, which can extend external bus cycles up to 7 meter per cycle. General purpose IO pins, which are branch control input output BIO to monitor peripheral device status, XF pin signal to external device via software. Parallel input output ports are 64 parallel input output ports. Serial port interface, buffered serial port, TDM serial port, host port interface to interface host device to C5X, user unmaskable interrupt due to external devices. This is it from our side. Thank you, sir.